Okay, so our notes, title of our notes, writing equations of the secant and cosecant functions. Okay. Um, the the forms of the functions that we're looking at. So if it's a secant function, it'll be in this form: y equals a times the secant of bx. Or if it's in the form of if we're looking at a cosecant function, it'd be y equals a times the cosecant of bx, where the absolute value of a is the amplitude. Okay, and that kind of gives you a, remember your quiz question? What's the amplitude? And we had like an m in front of the function. It was absolute value of m. Okay, not m, absolute value of m. It's got to be positive. And the period of the function is 2 pi divided by b. Okay, so that's the relationship between the period and b that you see in that function. We have helper graphs. Like when we were graphing the secant function, we first graphed the cosine function, right? The reciprocal of that function. And the reciprocals of these functions have the same amplitude and they have the same period of the function. So what you could do is if you're working on, say, a cosecant function, you can work on the reciprocal of that and find the period or the amplitude of that, and they're going to have the same one. So that may be helpful when we're looking at these. Okay, so let's take a look at an example. So write the equation of the following graph. So I'm going to draw these vertical dashed lines, which we call what? Asymptotes, right? And my function is going to look like this. And I'll give you some values on the x-axis. And also on the y-axis. Okay. And we want to come up with an equation for this function. So what I encourage you to do is draw the helper function. So wherever there's a minimum or a maximum, we're gonna draw our sine or cosine curve so that it hits those values. Okay, so here's a sine curve as we see, and actually we only need one period of it. So here's one period of the sine curve, and that's giving me some information about what we're working with here. So since I'm using the sine curve here as a helper graph, I know I'm working with what, secant or cosecant? cosecant because cosecant's the reciprocal. And so my helper graph, is it the positive sine function or the negative sine function? It's a negative sine function because it's from 0, 0, it's dropping down. And so because it's a negative sine function, I know I'm working with a negative cosecant function. Lastly, what's the amplitude here? 10. So I know already, just by looking at this helper function, I can get y is negative 10 cosecant. The only thing I don't know right now is what b is. But you can get the shape, I mean, you can get that negative 10 and that cosecant pretty quickly just by having a helper graph in here. Now, in order to find b, we need to be clear on what's the period of this function. And it may be hard to, you're new at this, so you may be hard to know, okay, well, when does the period end for this cosecant function? Maybe not sure. But we've been doing sine and cosine a little bit longer, and I just drew only one period of our sine function, and it has the same period as what we're looking at. So the period of the sine function is 4. So the period of our function is also going to be 4. And so I'm going to use 4. And I know that that's equal to 2 pi over b, and that equation is going to help me solve for b. So I'm going to set up a proportion here in which I cross multiply and get 4b is 2 pi. I'm going to divide by 4 and reduce my fraction, and I end up with b is pi over 2. And so now I can write my equation y is negative 10 times the cosecant of pi over 2 times x. Question on this one? Yeah. And then set it equal to 1, or? So you multiply what times what? 2 pi. For what? What are you trying to find? Example 2. Find the equation of the following graph. So this one's going to look like this. And I'll give you one value on the x-axis this time. We tell you that this is 7 over 3. And I'll give you one value on the y-axis. Let's say that this is 5. Now I want you to come up with the equation of this graph. So take a minute or two and try it out. So what kind of function is this one? Secant or cosecant? Secant. Okay, when you draw your helper graph, always start at the y-axis. So if I start at the y-axis and I go from the max, I'm going dropping down, going to the min here, back up, and I notice that's not even a full period of the cosine function, is it? So I need to go a little bit more to draw my first period of that cosine function, which means I don't even have the first period of the secant function here, right? 7/3 should not be the period of your function. because that didn't make it quite far enough. So I see the amplitude is 5. Is this a positive cosine function that I graphed or a negative? Positive, so I know it's going to be positive secant. So we should all start with this. Y is positive 5 times the secant of not sure yet, b times x. And then we got to figure out what's the period of this function. Any ideas how to come up with that? Good. So if you didn't hear that, we want to, we're 3/4 the period of the function right now. Right, if I label all the critical points on the y-axis here, or sorry, the x-axis here, we've gone 3 equal parts to make that 7/3. So we divide that by 3, we can go back to our first critical value. So 1/3 of 7/3 is going to be 7/9. And then we can count by that interval. So we got 14/9 here. And then 7/3 is the same as 21/9. And then add one more time, you get 28/9. And that's one period of our function. Divided by 3/4. So yeah, because what you're doing is you're dividing by 3 and adding and multiplying by 4. Yeah. And so then we know 28/9 is the same as 2 pi over b. Cross multiply, get 28b is 18 pi. And so b is going to be 18 pi over 28. Reduce that, 9 pi over 14. So our y equals 5 times the secant of 9 pi over 14 x. How many got that? Okay. How many got stuck on that period of that function? That was a little more challenging to come up with that. Okay. Let me give you one more. Okay, one more example here. Any questions before we leave this one though? Hold on to it. Okay. Okay, last example. All right, so we have a mark on the y-axis at a height of 7, a mark on the x-axis at -5, which lines up with the kind of the minimum of that relative minimum of that function there. And here's we got to decide if it's secant or cosecant and come up with this equation. So take a few minutes, try to get this one. Okay, so helper graph here. By wherever your vertical asymptotes are, that's where your helper graph's going to cross the x-axis. Wherever there's a minimum, that's where it, actually ends up being a maximum for your helper graph. So this is, we recognize the sine function, okay? We have to decide, is this a positive sine function or negative sine function? We're used to it being on the other side of the graph. So if I continue this, I see, oh, it's moving up here. Right here's one period on the right side, and so that's a positive sine function. And so amplitude is 7. We should end up starting with y equals 7 cosecant of bx. Okay, so that's kind of our first stage of thinking about this equation. And then we want to go after the period of this function. In other words, we want to figure out what numbers goes here, right? Because that's where the first period of the function is. If we can figure that number out, then we're good here, right? Well, we're given -5 on the left-hand side. Where would +5 be? Right, this is kind of like 3 critical values to the left. So if I go 3 to the right, 1, 2, 3, that's where your +5 would be. And we can cut that into thirds. This would be 5/3. And this would be 10/3. And this would be 15/3, which is 5. So now we know our missing number is 20/3. And that's the period of our function, which is 2 pi over b. And so we can cross multiply and get 20 times b is 3 times 2 pi. And divide by 20 and get b is 6 pi over 20. Reduce that and get b is 3 pi over 10. So our answer should be y is 7 times the cosecant of 3 pi over 10 times x.